Hi, everyone. Thank you for joining us today for our webinar, Introducing Phase Changes to Your Student. So I'm going to introduce your presenters today. We have Melissa, who's our chemistry staff scientist. She's been teaching for 7 years at the college level, including general chemistry and biochemistry, organic chemistry, and etc. She has 10 plus years at Vernier, so she's been helping with a lot of product development and help in our chemistry tech support area. And your other presenter is Noose. He has 34 years of high school chemistry and physics teacher experience in Frederick County, Maryland. He's been using Vernier equipment for a long time, since 1984, and he has been with Vernier as an employee for 5 years, and he does a lot of trainings and professional development and conferences for us. So I'm going to pass it over to your presenters.
Hi, everyone. I'm Noose, and Melissa, did you want to say anything before we get started?
Sure, I'll just say hi to everyone. I'm going to be helping Noose out with questions. So again, just like Angie said, if you have any questions, feel free to put them into the Q&A or just put them into the chat window. And I'll get to them, or I'll interrupt Noose and make sure he gets to it. No problem. Yep. And yeah, so look, we're glad to have you with us today.
So yeah, let's go ahead and start thinking about what we're going to do. So I taught chemistry and physics for 34 years in Maryland. And, you know, every year it's like trying to find the best way to teach a topic. And what we were talking about with this particular presentation, Melissa and Elaine and I, the chemistry group, was, you know, what sorts of things do you do early in the course that, you know, might be enhanced with using probeware? And this is a very common one. I did this with my physical science kids. I did it with my chemistry kids, not AP level. This is, you know, we're talking about, you know, like a first year level chemistry group or your physical science kids. What we're going to do today, and like Melissa said, you got any questions? I mean, this is a small group. You can just pop in and talk if you want, but you can also just put it in the chat or whatever if we say something too fast. But what we're going to do is we're going to do a couple of things. We're going to collect data, but also we want to show you something that was developed specifically with the pandemic in mind and the need for, you know, being able to share data. These days, everybody likes that ability to do that. And so we're going to look at that today. You know, what sorts of things would you expect? I'm going to throw in a bunch of my personal, you know, things that I look for when I was teaching, whatever. So, but please don't hesitate to just jump in there and just say, hey, Noose, how'd you do that? Or where did that thing come from? And yeah, as Angie said, the webinar is going to be recorded. So if you know anyone who couldn't make it for whatever reason, they're more than welcome. We have a bunch of files I'm going to share with you too. So there's a link here, and either Melissa or Angie will throw the link into the chat. But it's also, you know, this will all be available later, so don't feel like you need to write a lot of stuff down. I want you to kind of enjoy it, and if you see something, please just jump in, you know. So what sorts of things do you teach in a chemistry or physical science course when you're teaching the chemistry part of it early on in the course, you know? And so that's what we're going to do today. We have a bunch of support things set up on our website for teachers. One of the reasons why I stayed with Vernier so long, I know Dave Vernier from almost the time he started the company in the early 80s. And people would ask me, you know, why do you stay with them? Why don't you go with other companies? And one of the big reasons is because everybody at Vernier is a teacher, at least all of us, like in the tech support group. And so we've all been there. No one's been there like you guys have with pandemic. I don't want to say that, but we've definitely been there as far as, you know, setting things up and what's the best way to do things, and just get super great support from Vernier. And so that's one of the reasons why I've stayed with them. So in chemistry, you know, what do you do in, say, physical science, physical and chemical properties? What do you to teach? And so that's what we're going to look at today. Let me show you my screen, my lab. I'm at home. Okay, so this is my lab right here that you're looking at. But this is not a dangerous experiment. You know, this is one that you could do anywhere. What we're going to do is we're going to look at phase changes, but I'm also going to put a little twist on this for you, and I hope you find it amusing. I know my students did, and so I'll show that to you as well. I'm going to do the experiment with Vernier go direct temperature probe. This experiment, you know, these didn't exist when I was still in the classroom 5 years ago. So I've done this one for a long time with, you know, plugged in sensors. So don't feel like you're stuck with that, you know, that this is the only way you could do it. That is just not true. And what I'm going to use is I'm going to use as a guide a little bit, although, you know, I've done it a few million times. We have this lab manual called Chemistry with Vernier, and this is one of the experiments. I'm going to start with this experiment, but then I'm going to show you how I'm going to modify it to make it a little bit of a twist, and I will see what you think of the twist here in just a bit. And so that's where I'm headed. And so what we're going to do is we're going to collect data in our software called Graphical Analysis. And if you have this already on your device, particularly if you have it on your phone or something that's you're not watching the webinar on, this would be great. If you because it's kind of neat to share this with you. You know, I don't know where everybody is from, but yeah, we did some training not too many weeks ago with teachers all over the world, and we were able to do this kind of thing. And so I think it's kind of amusing. So if you have this already on your device, then this ideal. If you don't, and you'd like to try this, because I'm going to be collecting data for a while today, so don't feel like you're locked out. You know, go to Vernier.com, and at Vernier.com in the top here it says downloads. Download Graphical Analysis onto your computer, or you know, if you're going to do it on your phone, if it's an iPhone, go to the App Store. If it's a Google phone, go to the Google Play Store. If you're going to do it on a Chromebook, go to the Chrome Web Store. It's free. So if you don't have it, go ahead and grab a copy of it, and you can play along with us. But here's the plan. Let me show you what's going to happen here. I'll get things kind of started. If what we're going to do is we're going to make all of your copies of Graphical Analysis the Pro version. Okay, so everybody will have the Pro version today who wants to. It's just going to be like a little temporary version. It's a couple of weeks. We do offer an option where you can get a 30-day free preview if you'd like to try it for a longer period of time. I have my iPad here, and I do this on purpose when I train so that I can see what you guys are seeing. And so that's what this writes. This is my student. This would be what your screen might look like if you start Graphical Analysis up right now. You might get a screen that looks very similar to that. And the code that we need for this is right here. And I think Melissa or Angie will put that. Whoops, sorry about that. They'll put that code in the chat so that you'll have that to type it in. And here's what you need to do. Here's my iPad. So let's pretend that I'm you. Okay. So in my iPad, I'm going to go in this box that says activated additional features. I'm going to go in there and I'm going to type that code, and it does have to be exact. I mean, it's kind of like a password sort of thing. So you do have to be a little careful about how you put this in. The beauty of it is that once you've done it once, and this would apply to your students, by the way, it's done. And you wouldn't have to keep entering it into the same device over and over again. So, you know, it's one of those things that you pay for it. This what we're going to give you here for today is actually a paid feature. You know, you like I said, once you've entered it, you don't have to enter it again. It actually kind of remembers. It's kind of weird how the software guys did it. And so if I did that right, let me check there. Z5U capital A capital S K-F2. Yeah, I think I got it. So what I'm going to do is I'm going to tap submit. And what happened there is my iPad now has the Pro version. Okay, and it's telling me at the bottom here that I've got 12 days. You'll get, if you get that code in there, you'll get that same response. It's good for, just for us for today, so we can do a nice, fun little experiment. And like I said, if you want to try it with your students, take that code and share it with your students. You're totally welcome to try it and see what you think. But anyway, let's get back to the experiment. Let me go back here. Here's I need to activate my computer copy. So let me go see, somebody put this in there. Melissa looks like she put it into the chat. Let me go grab a copy. And nice thing it is when you're on a computer, you can, so what you end up getting when you get this from us is you get a license key that looks very similar to this, and you share it with all your students. The way most Vernier software works is that you buy a license for the software or the lab manuals or whatever, and then that is for your whole school. It's for your teachers and all your students and whoever wants to use it. But anyway, let's do an experiment. I'm talking. Okay, so let me get the camera up here so you guys can see what I'm doing. So this is a pretty classic experiment, right? You want to teach your students a little bit about phase changes. What does a phase change graph look like, that sort of thing. So what I'm going to do, and I'm following, if you have access to the folder, you're welcome to open it up. I'm following this procedure right here. Okay, pretty close to it. Because of the workshop and the amount of time we have, I'm going to speed things up just a hair bit. You'll see what that is in just a second. So I'm going to get, now one thing you do need to be aware of is that GoDirect sensors, because of this bit up here that has the electronics in it, they don't go all the way down into the standard test tubes that we all have, right? If you try to put it into a test tube like that, you can see a good hunk of the probe doesn't reach the bottom of the test tube. And for this experiment, it needs to. So if you're doing experiments in which you're using test tubes with the GoDirect sensors, you need to get smaller test tubes, to fit. You need to do a small adjustment. I think this is in the teacher pages of our experiment files. So what I'm going to do is I'm going to put, and this is a little pro tip from a teacher who's used this lab for 30 years, maybe, ever since the first Vernier. Let's see, what was it called? It was called Chemistry with Computers, not Chemistry with Vernier. When Don Volz wrote this lab way back in the 80s, I think, is when the first book came out, late 90s. So, and the lab calls for 5 milliliters. I'm going to do 3, partially because it saves time, and it just seems to work really well. And so I'm just going to get 3 milliliters. Now, it is super important. You may have noticed me rinsing stuff. It's super important that everything be clean, right? Tap water, not going to get good results. Okay, so you're going to need good, clean, distilled water. Okay, so I'm going to put the 3 milliliters into the test tube. Kind of funny, just kind of happenstance, that we have this thing called an electrode support, and this little test tube I bought, and if you're curious, send me an email or something and I can look up the exact dimensions of it. I don't remember now, but they fit right in the electrode support. I mean, you can hold it with a test tube clamp, but it just, by chance, it just happened to work. I was like super surprised. Okay, let's see.
Yeah, I was so excited when you found that. I was like, that's the coolest thing. We need to get more of those.
It's just handy, right? I mean, because the clamps are sometimes they slip and whatever, plus they get in the way. So this is a smaller footprint here. So anyway, let's set the experiment. So anybody use Logger Pro? Okay, yay me. Okay, Logger Pro has this way of collecting data that we had all these like setup experiment files, and a lot of teachers were not super thrilled that we don't have that on a LabQuest, we don't have that on Graphical Analysis, but setting up an experiment is so easy that and actually it takes away some of the black box business about how to do this. Let me show you what I mean. In this experiment, we need to go a little longer than 180 seconds. If you look at the x-axis. The x-axis here is showing that I'm going to run this experiment by default would go for 3 minutes, and we may need a little more time than that. In the experiment files, we have actually worked this all out, so you don't have to like go home and try every experiment. We recommend you do, but you'll notice that it says here, set the data collection settings 0.2 samples per second, a little bit slower rate, and for 900 seconds. So if you're using 500 milliliters of, 5 milliliters of water, then you would need that. For what I'm going to do here, just to stay with the instructions so I don't confuse anybody, I'm going to do the same thing, but we probably won't need all this time, okay? So you just tap on the bottom left corner, you set those settings, and then we're pretty close to ready to go, okay? This is one of those, normally I start collecting data, then I do the pro side of things with you guys, so that you see the data coming in, but I have to work over here because I have to do some stuff. So we're gonna go ahead and pro you up right now, okay? Here's how we do it. Okay, I'm the teacher, you're the students. Let me get my my iPad up here. Okay, so there's you or me. That's my iPad. And so what I need you to do, if you've got you've got pro'd up your graphical analysis, I need you to tap here where it says data sharing. So tap on that, and then I just need you to wait, hold. Okay, that's the student. Now the student could be anywhere, right? I'm the teacher. I'm going to tap on this Star Wars TIE fighter up here. This little thing looks like an antenna or something, and it's going to say start a data sharing session. So I'm going to do that, and you're going to get a code in just a second. Let me zoom it up so you can see it. So notice that's a lot easier to type in. So I'm going over to my iPad, and I'm typing in that code. My fingers are dry and it's just not doing it. IEB and 2KF. We asked the programmer guys if it was possible to make these a little less complicated, so that, especially when you're on a phone or something, that it was a little bit easier to type it in. So Melissa, did you get that into the chat? Yeah, you did. Okay, cool. I can always bring it back if you need. Now, if you look at if you've been following along, if you look at this is my iPad here, bottom left corner, it says we're data sharing. Okay, so we're pretty ready. Okay, now let's go ahead and get that out of the way so you can see what I'm doing. Okay, so in this experiment, what you do is you make a water bath, okay, ice water bath. And so let me put a little more ice in there. And then you start collecting data. Now watch your screen. If you are proing with me, watch your screen. Okay, here we go. I'm going to start collecting data. And I'm looking for the inchworm, right? I'm looking for, a little bit of data coming across. There it is. Notice it's right there. Bottom left corner, or probably right corner, there's a little live meter. It's possible to turn on a meter on the screen too, but I want that little inchworm coming across. And then what I'm going to do is I'm going to take my test tube and water, distilled water, and put it in my ice water bath. And then what the lab says to do is add some salt. If you ever make ice cream with your students, I used to do the baggy ice cream after this experiment. So want to be careful here. You don't want any of that salt to end up in the test tube. That would be a disaster. The thing will never freeze and it'll drive you crazy. Okay, so you want to get, I think it says 5 spoons of salt in there. You're going to hit saturation. Of course, I did a very poor job of being careful how much ice I put in there. I think that's going to be plenty. So, and then you're supposed to move the probe up and down a little bit. Are you guys getting data?
I am. I'm getting data.
Anybody in the group
How about anyone else? Let us know. Put it into chat.
Yeah, let us know if you're getting it. It's just, to me, especially, I want 2 things. I want to know where you are. Okay, because if you're like 1 mile down the road, that's one thing. But if you're on the other side of the country, I think that's really cool. Okay, because then you're like, whoa. So yeah, I gotta get my ice water bath here. Just make sure that guy is right in the ice.
Yeah, Barbara's getting data in Nebraska.
All right, yay, Barbara. So isn't that cool though? I mean, it's like I'm in Portland, Oregon, or we're near Portland, Oregon, and you're in Nebraska and you're pulling data down for me. It's like, I just find that amazing, you know. It's just, I don't know, you know, maybe I'm old school. I mean, but I just think it's kind of neat that we can do this now. You know, in this day, you know, we don't know what's going to happen the next few weeks. I mean, it's getting a little scary with some of the numbers around the country. You know, but I had a friend, you know, during the COVID last year during the fall when they were in hybrid. They were in New Jersey and they were in hybrid. He was teaching AP Chem, and he was dreading the thought. He had kids coming in on Monday and Tuesday, and then he had Wednesday was like office hours day or something like that. And then what they did was they had like the other half of the class came in the other 2 days. And so he was dreading having to set everything up twice. That was his big worry. Was like, I'm going to do these labs, and it's like acid-base titrations and all that kind of stuff. And so I told Steve, I said, "Do you want to try Graphical Analysis Pro?" And so I gave him a code just to a 30. We have this 30-day trial thing that you can do. And so here's what he did. He had half the class at home, half the class at school. And what he did is he set up his lab groups so that the kids at home and the kids at school, so it'd be like 2 at home, 2 at school, that were in the same lab group. And then what they did was that they probed the data like we're doing right now with the kids from school, with the kids at home. And so what ended up happening was that instead of doing the labs twice, he only did them once. And and his school did allow the students to use their phone, the camera on their phone, so that they were able to share the, to also show their friends, what was going on in the classroom. And so it was kind of a neat arrangement that he was allowed to have. And I don't know if that's unique or whether it's that's something that other people would have the ability to do, but yeah, it seemed to work pretty. Oh, it's sticking. So what I'm feeling for is sticking. Oh, Mr. Harrison, the temperature's going up. My students would say this all the time. Yeah, Mr. Harrison, what's going on? The temperature's starting to go up. So once you start to feel it stick, you can let go. Stop doing what I'm just giving it a little tap here. So you might know about the supercooling dip. But the idea is that you, once it starts to stick, you know that the crystals are forming now. Basically it's going to form a popsicle in there. And that's the plan. But that was concerning for my students, right? It's like, temperature's going down. Now it's starting to go up. Think about all the discussion you can have with potential energy, kinetic energy. We used to play games back when we could touch each other, where we would like be free water molecules, and then all of a sudden we're sticking to other water molecules, And so what's going on? Well, it's warming up. If it's warming up, then heat must be coming out from somewhere. Where's it coming out from? So you can have, this can be a really rich discussion as far as, what's going on in this system in terms of energy changes and so forth. And of course, water molecules tend to have this great supercooling dip here that's just kind of interesting. So the idea would be, and then from here on out, you would have the students, like how low can you go? So, right now the temperature is constant. What's going on? If you're careful and you just barely touch the probe, you can see that it's stuck. You can't, unfortunately, with this setup, and I'm going to show you something different in a few minutes. You can't really see it real well because of the ice cubes being in the way and so forth. But with other substances, we're going to do some lauric acid here in just a minute. It's air cooled, and so when it's air cooled, the kids can actually see what's going on. But we've got, during the phase change, we've got both phases present. We've got the liquid phase and the solid phase present. And until all of the liquid turns into the solid, the temperature is going to stay pretty constant. And then at some point, we're going to start seeing, we hope we're going to start seeing that the temperature is going to drop. So that's what I'm looking for now. Anybody have any thoughts while we're kind of waiting for the temperature to drop off a little bit? Don't all talk at once.
Well, I was going to say another great use of the GA Pro is for if you want to share, if you're doing a demo at the front of the class, to share to your students that data, or your students at home. But also if you have students that have amazing data and you want them to share with the class, or if you're distancing in your labs and you're set up in 2 separate labs, it's a really great, I've heard some teachers that are doing that. So it's a really versatile thing to be able to share data over distances, but also within the same classroom. It's pretty cool. So.
Yeah, and one of the things, I mean, I think I mentioned earlier that, I'm a Logger Pro user from way back, and I'll bet there's a few of you in the audience too. And, you can't do this in Logger Pro. I mean, there's some of this can be done, but it's all limited to being on a computer. This day and age, when it's bring your own device days, there's Logger Pro doesn't work that way. I would say, Melissa will probably back me up, that I would say we get multiple calls or emails a day that say, how do I put Logger Pro on a Chromebook? And you can't. You just can't. The software is not designed to work that way. Logger Pro is great software. Don't get me wrong. I used it ever since it was brand new. But it's getting aged. I mean, it's just getting huge. It's, there's some things it just can't do. But this free piece of software, now it's not quite as free because we added this code, but there are ways to collect local data that is still free, that's built into Graphical Analysis, and it runs on anything. It literally runs on, whatever you got. Now you got to be careful. Some of the older stuff, we've had some customers, I was telling Melissa earlier, we had some pretty aged Lenovo's in my school, and they were having some trouble with some of the stuff just because they were so old. So there is some of that. So but yeah, it's pretty phenomenal that I'm collecting data on a Mac. This is my iPad. Melissa's on a Windows machine. She's pulling it down. I mean, it doesn't matter. There's just that area of, gotta have this specific piece of hardware. Okay, we are now, take a look at your data. We are to the point where we've reached kind of a minimum temperature. You can see it's leveling out at this point, and that's good enough for our 1-hour workshop. So I'm going to stop collecting data at this point. And so what the students would have to do at this point, and I don't want to disconnect from you guys, but normally if you were having your students analyze the data, then you would disconnect. I would go here and I would stop sharing it and have you guys do the analysis on your own. Right now, I got a feeling I might be pushing my analysis out on you, but we would have the students take this average value right along in here. And so in graphical analysis, let me get rid of the meter because we don't really need the meter. You would highlight the area that you want to look at, the flattest part of the graph, and then you would go to statistics under the graph tools icon, and we'd get a value for, I'm not seeing it pop up on my iPad, so I got a feeling if you want to do this, you're gonna have to do it yourself if you've got data. But you'll notice, not bad, right? Mean value of -0.2, not horrible, and it kind of depends on how you select it. It looks like it was dropping off. If I select it a little more where it's flat, I can zoom in, I can, zoom into more, area where it's more flat, and then do the analysis there, and you can see maybe it's slightly better, not by much, but slightly better. So the discussion, well, why isn't it 0, Mr. Hism? Well, this is a scientific experiment, and there's going to be error built in. Maybe something wasn't clean. All right, part 2. So part 2, what I need to do is start collecting data, but this time I need to warm up the water. So let's do this. So I start collecting data. Now what I want to do is I'm looking for that inchworm once again to come from the left over here, and then the water bath becomes an air bath, right? And so the idea here is now you can see the popsicle, right? We couldn't see the popsicle before, but boy, it is a nice little popsicle there. And what we're going to do is we're going to replace the water bath eventually we're going to replace it with a warm water bath. But in the experiment, what it says to do is to allow the, my beaker froze to my stir plate. There we go. We want to allow that to come up, and we want to see, what the, compare the two. Well, what news? Where's the other one? One of the things that, kind of a change from Logger Pro and LabQuest from the past is that with graphical analysis, anytime you start collecting a new set of data, the old set of data is still there. So if you tap on the y-axis label, you can see the original set of data and you can see the one I just did. So I can turn them both on. And yes, this is getting reflected to you guys because it's sending you everything from me. But now we can look at this and we can say, I hadn't thought of it till just this second. We could have had the students predict when we're warming this up, what's going to be the temperature at with which this popsicle starts to melt, right? And so we should have done that, Melissa. I didn't think of that till this second. Should have had them predict it. But anyway, yeah, there's under the graph tools icon there is a little option for making a prediction. It's a little late to be doing that now, but we could have done that. We could have had the students predict what's it going to look like. And hey, look at that. We had an average value of about 0.2. And look what's happening right now. In the full lab, the students let this go for a period of time, and I will let it go for a small period of time here. I do have a water bath, a warm water bath sitting on my hot plate here. And so what I will do is I'll lower it into that to speed things up. Once we got a nice flat spot, water has a huge specific heat, and even when it's ice, its heat of fusion is pretty high. And so, you could wait a long time for all the ice to be melted. I mean, right now, if you look in there, we've got kind of a mixture. You can see the temp probe is now moving because there's liquid and ice. And this is of course an important concept for your students to recognize that we have both phases present here. Later on, when you're studying things like heat in general, thermochemistry or heat in general, and you're calculating the amount of energy it takes to take some ice and melt it and maybe boil it at some point, you're going to have to deal with the fact that delta T is 0. Well, if delta T is 0, how do you use Q equals MC delta T, right? I'm lowering it into the warm water bath just to speed things up here. We've got plenty of flat spot there. In the lab, it tells you specifically how long to wait. But I think for our little workshop here today, I want to do the other substances. So, and I'm going to tell you how I used to do that in my classroom. I don't think I have a picture. I have lots of pictures of my classroom, but I don't have anywhere, and it's just short-sightedness on my part of my students actually seeing this, because if you saw their faces when we look at the next part here, you know what I was talking about. But yeah, the temp probe is almost completely free. The ice is almost gone. This is a warm water bath. Just hot water from the sink is plenty for this part of the experiment. And look at that classic shape. Right? I mean, we have these in the textbooks, but and how long have we been going? We talked for about 5 or 10 minutes, and so maybe 20 minutes, right? And so even the shortest classes, I will tell you, cut back on the water if you have a short class. So cut back to like 3 milliliters. The other thing is, and I've always complained about this picture, but I understand why they did it. In the picture here, well, this is interesting, Melissa. This picture doesn't show any ice cubes at all. The old picture had 3 ice cubes in here. And no good. Got to have lots of ice cubes. I'm going to stop data collection because obviously it's all melted. But yeah, you saw when here's my ice water bath, right? And to the point where it overflowed, I had this towel here. You want that thing full. In my school, we had that shaved ice from the cafeteria. Beautiful, got really good results. Okay, so you've got it on your end. I've got it on my end. Let's check the melting temperature. So we're going to drag across that flat area, and we're going to do a statistics. So you're going to tap on the graph tools and do a statistics. And look, negative 0.2 within significant figures. It's pretty close. Oh, what? Let's compare that. Let's get the other one up there. Neat thing about graphical analysis is that you can have more than one set of statistics on the screen. So look at that, negative 0.19, negative 0.22. Within experimental error, that's probably really, really good. Whatever is causing that slightly depressed freezing point and melting point is consistent, at least. And I'm not sure what that might be. All right. Last thing I want to show you as far as this experiment goes is what about other stuff? In the folder that we shared with you. So in this folder, let me bring it up here. I had it up earlier, and then I think I got distracted. Here it is. Got this little file that I created because I've been fooling around with this for a long time. And, you know, water's water, and, you know, 0, 0, it might be exciting, might not be, depends on the level of the student. But what about other stuff? So here are 3 things I've tried just in the last few weeks and that do work really well. The lauric acid works super well, and it's a relatively low temperature. So I've got that handy right now. We're going to do that. But these, you could do with any of these. The stearic acid is kind of amusing because the temperature is pretty hot, pretty steep. If you look at my camera here, I've got a hot plate back here, and I've got some lauric acid sitting in the hot plate. Let's get Temp Probe out and just kind of give it a little wipe. I don't want it to be too messy. Okay, and this, I don't need this thermometer anymore, so let's get that out of the way. And what I'm going to do is I'm going to go back to graphical analysis, and I guess I could turn these things off because we don't need them right now. And I'm going to take the temp probe and I'm going to stick it in the lauric acid. I put some sealer on the test tube the other day. Just let me get that off. Okay, so the idea is what we want to do is we want to get, and I'll turn the meter on so y'all can see what's happening. We want to get that temp probe up to the highest temperature possible. So let's give it a few secs. Had I thought this through earlier, would have been saved a second or two, but I think we're good on time. Does anybody have any thoughts, questions, concerns before the next part?
Hey,
so,
Nils, how do I keep track of which run is showing melting versus?
I'm glad Melissa's keeping me on track here. So I'm going to open up a data table. So top right corner is the view options menu. I'm going to open up a data table. And you'll notice that and I don't see it on my iPad, so I'm guessing that it's not, you have to do it yourself. I don't think that that's something that gets reflected over. And so the first run that we did here, it was the run where we were freezing the water. So if you tap where it says data set 1, the 3 little dots, you can rename it. And so that one was freezing H2O. Have a cute little tool for putting subscripts in, but I won't mess with that right now. And then I'll do the one over here. This one was melting. If you're doing a lot of runs, and we are going to do at least 3 today, must be touching something and causing it to jump over there. Let me see. I think I'm touching something up inadvertently on my screen. There we go. Now, if we look at the left axis, let me see if I can make graphical analysis a little bigger here so my tables aren't totally taking over everything. There we go. Now what did say data set 1 and data set 2, it's now reflecting the names of the runs. And there's an option in graphical analysis in the graph tools to turn on a legend. And so now the legend reflects the colors. And if you don't like the colors, like, melting, I'd like melting to be red. So I can go over here to where this icon or whatever you call symbol is kind of yellowish, and I can make that a red color. It's kind of a neat feature, that you can adjust those things. But yeah, if you do a lot of runs, it would be really handy. By the way, just in case anything snafus, if you want to save this, go to the file menu and then go to save. If you want to save this for the, if you think that my work is so great, but this would be the time to do it, is go ahead and save it. Let's go take a look at that meter. Let's see, where did the meter run? It's down here in the bottom left corner, but I'll turn the big meter on. I'll turn the data table off because we don't need it right now. Now, what I would normally do in my classroom, I did this all the time. I took these low melting things and I would put them in test tubes and put a stopper on them at the end, is I would run this before we even did the experiment. And so kind of maybe I have to use 2 temperature probes to have done it earlier, but you'll get the idea here in a second. I've got the temperature probe sitting in the test tube back here on the hot plate, and I'm ready. You can see the temperature is pretty high. So I'm going to go ahead and tap collect. I'm going to get rid of that legend because it doesn't mean anything. And now let's see. Is that little, there we go. There comes the little inchworm. So I'm going to take this out of the water bath, the hot water bath, and stick it in the, so what is the water bath for this particular part? Air, right? The air is the water bath. So in your classroom, what you might do is put one of these up and, as a demo, and just let it sit there, right? And you don't have to do anything. I mean, I'm going to speed this one up for us today, but you can have this just going on its own, like on another, maybe on a device that's connected to a projector or something like that, and just because you could, these Go Direct sensors also connect to LabQuest. So if you happen to have one of those, you could have one of those doing it or whatever, and just leave it sit there while the kids are doing the experiment on their own, for water. And then every once in a while, draw attention to it, right? And so have the kids go over and take a look. And right now it's very liquid. The probe is, it just looks extremely liquid, but it's going to start freezing here at some point. And ideally in your classroom, you've got a fair amount of time. You saw 20 minutes, and that's plenty of time. I'm going to speed it up a little bit and use some room temperature water. I've got some water sitting here that you can see that my fancy jugs here. I'm going to speed it up just because we have 20 minutes left and I don't want to kill all that time doing this. But in your classroom, I would highly recommend that you let it go. Just let it go, right? So I'm just putting this in here. When the temperature drops into the 30s, I'm going to pull it out. So let me see if I can get it to do that. So should do that. Listen, I tested this a week ago and it worked really great. So it's just starting to get there. I hesitate to put an ice cube in there. I could, but I don't want it to go too fast. That's why I said, if you can let this go in your classroom without putting it in a water bath or anything like that, that's ideal. I am going to go ahead and speed this up a little bit for us. So I put an ice cube in there, but I don't think that's the ideal way to do it. I think you should just let it go, and if you look at it, now the beauty of this one is, let me get the camera closer. Sorry if I'm getting you dizzy, but check it out. So now, have the students touch that, right? Now in the air, it's ideal because it's warm. And it's like, wait, it's freezing, but it's warm. What the heck is going on here, right? I mean, and look at the graph. It's the same shape. So we have this thing that's freezing, right? A whole new definition for, at least for the students. I don't think that's a new definition for us necessarily, but for your students, it might be. It's like, what does freezing mean, right? And so, but look at the graph. Now let's see, that thing I gave you, that table that I gave you, I put the melting points on there. So lauric acid, 43.2. Let's see how good we're doing. Okay. So you can see it's starting to drop off. This is room temperature water, so it's probably, 20 degrees or something like that. So you would expect that at some point it's all frozen. Oh yeah, it's all frozen in there. So you can see the temperature's dropping off here. But if you have this running as a demo on your demo table, and then the kids are doing the water part of the experiment, and I promise you, if you have it in the air so they can touch it while it's doing it, I mean, you're going to get some interesting responses from your students, like, and there'll be that bright kid that explains it to everybody, but there'll be some kids that are like, how can it be freezing? Because it definitely, oops, the camera's not there. It definitely looks like it's freezing. Look at that. Okay. And yet, when you touch the outside of that test tube, it is hot. Now, if 43 degrees, that's pretty toasty. Your body temperature is what, 37? If you do stearic acid, that one's 69 degrees, right? So yeah, so that one's going to be warm, quite warm to the touch. And it comes out very similar. In fact, in the shared folder, I'm going to stop this one because you can see it's dropping off now. In the shared folder, I ran all those, so you guys would have the data. So let's see, the most flat part maybe around in there somewhere. You can try this on your end if you want, if you got the data. What do we say, 43? Let's find out. Statistics. Look at that, baby. 43.3. Okay, what did we say it was? 43.2. That's pretty good considering I was rushing it a little bit here too. And the neat thing is you could have, Graphical Analysis has some great tools. Like you could have more than one graph on the screen, right? If you tap on the top right and you say 2 graphs, well, we could have, the lauric acid at the top, and we can have the waters ones at the bottom. So there's some features of the graph that are similar, and then some, okay, let's see, I've got 15 minutes. Can I do a melting? Melting is the hardest, by the way. I will warn you. You need a warm water bath, which I put somewhere. Where did I put my warm water bath? There it is. You need to get it started. Let me get it started here. Okay, don't need 2 graphs. Let me just turn on 1 graph here. And there it is. You can see it's around 20-ish room temperature, right? Let me lower this thing into the warm water bath. Don't make the water bath boiling water. It'll zoom right up and pass the melting point in a heartbeat. So, you want to make sure that the water bath is warm, but not, I mean, you have to be careful because I don't know what your water is like at your school coming out of the tap. If your water temperature, you need water over 43 degrees. And so that water was what I had on the hot plate, which was 60 something. And so let's see if I can get, I'm going to feel really lucky here if I can get the melting curve. Melting curve's the hardest one.
Hey, Noose, show your camera because we can't see the substance.
Sorry. Thank you.
Right.
Sorry. I tend to flip through the screens here and I forget what I'm doing. Yeah. I have this is the water bath that was on my hot plate. And it was around 60-ish degrees. And I put just so I don't have to sit here and do stuff, I put a stir in there. You wouldn't necessarily need that, but it's I will tell you, this is with the solids that I had on that chart. This is kind of tricky. And on the chart, I put a procedure in there to help you because I did it enough times. I thought, I should probably give some of my tricks away, to folks. But let's see, it looks like it's kind of leveling off. Let's see, Graphical Analysis, it's reading 41.8 right now. Okay. We said what, 43.2? So let's see how it does. Yeah, lauric acid works well. They all did. All the ones on there work really well. I will tell you that the phenyl salicylate has a huge supercooling dip. I don't know if you've heard of Project Lead the Way. They were very interested in phenyl salicylate. I'm not quite certain exactly why. So I did it for them more than a year ago. It was pre-COVID, and I was super surprised at the supercooling dip in the phenyl salicylate. I haven't looked at the molecule enough to think that through in terms of what's going on in terms of potential energy and the structures all getting close to each other and whatever. But there's obviously something going on there. So. But yeah, this one, you don't see it in lauric acid as much. I can't remember the stearic acid. In the folder that I shared with you all, there's a data file for all of them. So that I created a couple of weeks ago. So how are we doing? Well, it seems a little higher, 44.1. That's what I'm saying. If your water bath temperature is too high, you're going to miss the melting point. And so let me put the other one back up here. How do you put more than one up? Tap the y-axis. We know that this data set 3, which I'd never renamed, that's the freezing. So we'll bring that up and let's take a look at them. You can see a little bit digression there compared to the other ones, but it's not horrible, but it's not quite as effective or impressive, I should say, as the one we did before. Probably want your water bath temperature around 40 that's wrong, 20 degrees higher than the melting point. And so there might be a little bit of cheating there on your part in setting this up in advance. So, but you can see it's not awful, but it's the hardest one. I will tell you that now. You have to melt it to get your probe out. So be aware of that. I did have a towards the end of my teaching, I was able to get in touch with NIST, not NIST, NIH chemistry labs, and I did get some heating blocks. I found those were a lot more easy to control the temperature than water baths, but it was one of those things. They're expensive, so I would never have bought it myself, but they were giving them away. So, but yeah, it's not horrible, but not. I mean, maybe on the average, if you decided that maybe there's something going on here, you did kind of an average value. Let me show you those. I'm going to stop this, and if you like this data, remember you've got all of it now. So if you've liked this data, you might want to save it at this point. This was the lauric acid runs. So if you want to rename them, go to the data table. You have to do this on your own. Data set 3 was the freezing lauric acid. Data set 4 would be melting. I think this adds a little more to this activity. Some people find this activity maybe a little bit too simplistic, and it's not, if you add this other chemicals to it, neither of which of these have any really terrible SDS issues. Years ago we used paradichlorobenzene and acetamide and things like that you wouldn't want to use now. But these are pretty good. If you look at the SDS on these, they're not dangerous or anything. Like, don't eat them, but they're definitely not at that level of the having the cyclic things in there. But what I did do is I put in the folder, I did to all of them so that you guys could see them if you want. And so in that same folder, you have on my webinars folder here. It's in our Vernier fall. Here we go. There's one that says freeze melt data, not for water, but for everything. And so if you look at that one, it's got everything. Okay. Oh, that's cool. If you click join new experiment, you'll pull this down right now. But this is everything I did. So lauric acid, stearic acid, all the different ones are there. So that's interesting that I didn't think about the fact that I didn't cancel the sharing. And so if you want it right now, you could just join new experiment and you would pull it down immediately. But yeah,
hey,
go ahead.
How did you get that title lauric acid there on that second graph?
Oh,
that's pretty cool.
all the stuff that you want your students to do when they're doing a report is usually under this little mini graph tools icon. And if I edit, like you notice my top graph doesn't have a title. My students in my class would have lost a point for not having a title. So they need to go down and tap on the graph tools icon, edit graph options. And for this one, that was the water melting. Freezing. I guess this was freezing melting, wasn't it? Because I'm bass backwards here. Freezing, melting, water. So a lot of these options, you'll also notice you can change scaling and things if you have a need to do that under the graph tools icon. So then that's how that happened. The other thing that you all have access to now is in reports is the ability to export these things a couple of different ways. If you tap on the file name menu and go to export, the free version of Graphical Analysis allows you to export the graphs separately. So if you have two graphs open, it lets you export them as PNG separately. The Pro version adds the option for you to do a PDF, which then of course can have more than one. And so that's part of the Pro license. So if you don't have the Pro license, then this option will be dimmed out and it'll tell you have to pay for it to get it. But some people like that because it's got more things on one piece of paper. Either way, if you've got Pro or free, even the free version, if your students are creating reports, then they can export the graph. And one of the things I was doing right near the end, we were using, last 5 years, we were using Google Classroom. My ninth graders were having trouble always had trouble writing lab reports, don't get me wrong about that. But so I was trying to do more things electronically, and So what I did was I created a template for my ninth graders. I think I allowed some of my other students to use it too. But basically, what do you want in a lab report? Well, all the usual stuff. Your title, purpose, materials, and all that. Well, I like using slides for this. It was just easier to paste in things and adjust things. And so for like graphs, the students could go that graph that I just exported. If you're on Google Classroom, you might put it in Drive but I put it on the desktop here. So there's the file. So students can create reports in a heartbeat. This could be Word, this could be any Google Docs, but it really makes it easy for students to create lab reports. You can also, if you're teaching your students how to use Excel, you can have the file exported as a CSV. AMBL is the older version of graphical analysis, and there's some of our software reads AMBL files. Some teachers still like that, but yeah, it's easy to create a report. You will notice in graphical analysis there is no option to print, not directly from graphical analysis. So once you export a file, then what you have to do is use your operating system's ability, whatever it is, to print. So I'm on a Mac right now. So, I would use, if I just wanted to print something, I'd open the file and then just use the print dialog, and that would be true on all of your platforms. We're down to 5 minutes. I'm going to show you a couple more things in graphical analysis, but are there any questions that have to be answered before the end of the workshop? This remote data sharing is probably the premier feature of graphical analysis, but there's a number of other ones. And all of you that put graphical analysis on your device, you have these right now. The other thing is this thing that says See Experiments. If you tap there, a little bit of an homage to Logger Pro, maybe, not exactly, but a little bit of an homage. Melissa did all these. She collected data and then she linked them, all the chemistry ones. So since we're doing chemistry, let's look at those. So what you can do is you can pick some of these like a titration, and you can now open not only the data file, but also a video. So what she did was she created a video. We had a lot of questions, especially during the worst of the pandemic, where teachers and students wanted to see how to do an experiment. And so what she did was she collected this data. This data here is collected from this video, and actually not from the video, it was live data, which you can then synchronize with why am I not seeing the sync button, Melissa? Where'd it go off to?
It's because you picked a titration, which is events with entry, and
yeah, that's
you can't sync events with entry data.
Oh, that's right. That's right. Yeah, some of these, the time-based ones, are synchronized to the data set. So, I'm trying to think which one is synchronized.
The molar volume of a gas right there is
that one. Oh, that's right, because that was a pressure against time. Yeah. So what happens here is that this one you're measuring the pressure against time, and so what you can do is you click on the little doohickey there, and then you can synchronize the data to the video. And so that's what was done here, is that at so many seconds in the video, the data starts. Let me do it from here. And so the beauty of this is it shows the students the complete setup. And what Melissa did so well is she edited these so that the stuff that's a little more routine goes pretty quickly. But then what'll happen is and this I'm running this twice as fast as normal. So now when this is running, the data that's appearing over here on the left is actually synchronized to the video. Some places this is better than others, but at least the idea of where the students can see, oh, this is how the data was collected. You just see the jump in pressure when she injected the hydrochloric. I don't know if you're familiar with this. This is magnesium and hydrochloric acid making hydrogen gas. And so you can see that spike in pressure when she injected the hydrochloric acid. So that's a feature. There's in the slide deck for this workshop, there are some other mentions of different features that you can do with Graphical Analysis Pro, and we did create. Melissa, actually, I just cut and pasted it. This nice little comparison of the Pro version versus the free version. You can do all of our experiments in our lab manuals with the free version. The Pro version is not required. It adds some extra features. You can have your students videotape themselves and then synchronize their video with their data. That's also a feature of Pro that's not something that you can do in free. So I think I killed the whole hour. Melissa's laughing at me. Thank you, Melissa, for jumping in. Does anyone have a last second, how can I do this, or where do I get this, or whatever?
No, you've answered all their questions so far.
We are at, Melissa and Elaine and I are at chemistry@vernier.com. So if you want to write to that email address, you're going to get one of the three of us. You can also call and ask for us. We also have a chat feature on our website. So if you go on there, depending on who's available at the time, one of us will likely jump in on the chat and try to help you out. So if there's anything that we can do, please let us know. The video of this will be posted probably in a few days. We will have other chemistry related trainings coming up. What's the next one, Melissa? I can't remember off the top of my head.
Let's see. The next one is measuring the solubility of gases with soda pop.
Yeah. Do you teach that the solubility of gases goes down when the temperature goes up? We all do. We worked on a way to do an experiment where you can measure it, and you can plot a solubility curve for gases. And so that's what we're going to do in the next workshop. So
yeah, it's a very different take on anything that's in any of our pre-printed labs. So you'll definitely want to join that if you're looking for some outside the box ideas from our pre-printed labs.
Yep. So I'm going to let you all go. Have a good school year. Let us know what we can do to help you out. Okay.